All right, today we're still messing with right triangles, but they're not special. Can you see that this is not like a 30, 60, 90 or a 45, 45, 90 right triangle? He is just a average right triangle. Nothing special about it. They are asking us to find a missing side length in a right triangle. Well, that'd be cool if we could do the Pythagorean theorem, but you have to have two other side lengths, and we don't, right? So there is another way to deal with this, and it seems like it's going to be scary at first, but it's actually easier than you think. We're going to use trigonometry, right? And don't let that scare you. It's just basic right triangle trigonometry. And as weird as this is, there's three cool functions: sine, cosine, and tangent. You've probably seen these buttons on your calculator before that looks like sin, cos, tan. Well, they really stand for sine, cosine, and tangent. And here's the definitions of those functions, which would be easier explained if we just kind of dive into the question, right? So sine's definition is supposed to be opposite over hypotenuse. That's going to help us with this magic word. Sine is the opposite over hypotenuse. So we'll put this S for sine, O for opposite, H for hypotenuse. Then cosine's definition is adjacent over hypotenuse. So we have cosine adjacent over hypotenuse. And then finally, tangent's function is opposite over adjacent. So the magic word for this chapter is SOH CAH TOA, because it tells you what the sine, the cosine, and the tangent relationship is. So as weird as that is, let's kind of dive into this situation. They say in this picture down here, the measure of angle A is 48 degrees. We need to put that in the picture. And then check this out. They say little a is 9, but they don't have a little a in the picture. That's because little a is known to be across the side from capital A. So this is where like little a would be, and like little b is across from capital B, and little c is across from capital C, kind of stuff. So they say little a is 9. He's across the street from that. Find little c. Little c's got to be across from this guy. And can you tell that we have a right triangle, but we can't use like the Pythagorean theorem because we don't have enough information for that. It's also not special, so we're going to use trigonometry. So here's what we do. Just like we did after the test, we're going to focus all of our attention on this angle that we did right here and ask ourselves, who is this 9? Is he opposite to 48, adjacent to it, or the hypotenuse? And he, my friends, is opposite. So let's put a little OPP in front of there. Then we also have to ask ourselves who this guy is. This is the dude they want us to find. Well, being is how he's across from the 90. He is the hypotenuse. And here's where SOH CAH TOA helps us. I need to go find which one of these three dudes, sine, cosine, or tangent, deals with opposite and hypotenuse. And can you see that is this guy right here? He's the only one that has an O and an H with him. He's got opposite and hypotenuse. So again, this is brand new. Follow our lead. Here's what we do. We start with the trig function that deals with opposite and hypotenuse. He is the sine, so we'll write it down, and we'll use the same abbreviation that we'll see in our calculator. Like sine is actually spelled like this, but we'll abbreviate it with this dude. Then what goes next to him every single time is the angle measure that they are talking about. So like the sine of 48 will equal. And here's the other part of SOH CAH TOA that will help us. There's always going to be a fraction here. And the first thing you see, he is the opposite guy. So he's going to be, sorry about that, hit a button. He's going to be 9. And the hypotenuse is C. The definition will always be sine's going to equal opposite over hypotenuse kind of thing. So we've got this weird trig function. Don't let this thing scare us right here. He's just going to be right there for the ride. Our job is to solve this dude for C. Well, shucks, he is downstairs. We need to get rid of this divide by C by multiplying both sides times C. So we're going to do a little times C, and this is going to be C times the sine of 48 equals 9. And then as weird as this looks, you know, it's brand new at first, we just need to get rid of this times sine of 48. You just got to like realize he's not a 48. He's like the sine of 48. So how do you get rid of a times sine of 48? You divide both sides by the sine of 48. And that, my friends, is what's called the exact answer to this. But of course, nobody knows how much that is until we punch it in the calculator, which can be tricky because your calculator has to be in the right mode. So if you can kind of follow my mouse here, the mode button on my calculator is right here. And I have to make sure that, do you see this dude right here that's flashing where I have the radians versus the degrees? I need my calculator to be in degree mode because that's how we measure angles in geometry class. We do it in degrees. There is a whole other way to do it in radians. That's for an advanced course that we may or may not take in the future. So degree mode is what we need. So if your calculator's not in degree mode, we need to switch it over there. You just move the black box, and hit enter. So do you see how I moved that black box over there? If you have a different calculator and you can't figure out how to put it in degree mode, show your teacher and we will help you out. So then to get out of this, you hit second quit if you went into this menu. But the easiest way to tell if you're in degree mode is to hit hit the sign button and hit 30 and see if you get 0.5 back. Like if you get 0.5 back, you're in good shape. So anyway, back to this question. They say that the C is going to equal 9 divided by sine of 48, so that's what I need to punch in. 9 divided by the sine, so that's the SIN button right here. And you see how it automatically puts a parenthesis with me? So like it would be a good practice to start closing that parenthesis when you're all said and done. So 9 divided by the sine of 48. And we're going to get some nasty decimals on these bad boys. So we're going to just round them to the nearest tenth. That would be 12.1. So C is about 12.1, which does make some common sense because it is the hypotenuse. It should have definitely been longer than 9 in that case. Weird. Let's get better at it by trying more. So here's how you start. You put the info in the picture. They say measure of angle B is 28 degrees. Little b is 3. He's across from big B. Find little a. Little a is over here, right across the street from big A. So we put the info in the picture, then we focus all of our attention on the angle they gave me that's not 90. Like we don't get to use the 90, he doesn't count. So we realize, who is this 3 in relation to it? Is he opposite, adjacent, or the hypotenuse? Well, this guy is straight across from it. Then who is the A? Well, you can do it a couple of ways. He's definitely not the hypotenuse because this is the guy across from the 90, so he has to be the adjacent to this guy. And the other way that I showed you guys on that video was he's the dude that touches the 28 and he's not the hypotenuse. So we're dealing with opposite and adjacent. If we go up to the magic word, this is a very important word because it's going to tell us which trig function to use. The one that deals with opposite and adjacent is the T dude. He's called tangent. So how we'll set up our equation, it's always the same setup. It'll be the trig function, so it's either sine, cosine, or tangent. In this case, it'll be tangent. What goes next to that every single time is the angle measure. And then tangent's definition is opposite over adjacent, right? It's always the first letter over the second letter. So opposite is 3, and adjacent is A, right? You see how I set that up? So that's the equation. Trig function, angle measure equals first boy over second boy. Now let's solve this for A. This stupid down in the denominator again. So we got to get rid of it by multiplying both sides by A. So A times the tangent 28 is going to equal 3. You see how those canceled each other out. And then I just got to get rid of this times tangent of 28 by dividing both sides by the tangent of 28. And once I get to that point where I got A all by himself, that's when we go to the calculator and we punch him in. So 3 divided by the tangent of 28, close that parenthesis. And we'll get a nasty little decimal right here. He's about 5.6. So A is about 5.6. So weird, but it gets easier and easier and easier as the chapter goes on. And by the way, this only works if you have a right triangle. You have to have a right triangle first. So we'll put the info in the picture. Measure of angle A is 70 degrees. Little c is 58, so that's going to be across from big C. And find little b, that would be right here. So we have a right triangle, and I have a mixture of side lengths and angle measures. That's kind of like another clue that you're going to use SOH CAH TOA to figure this out. So focus all of our attention on this guy and decide who these dudes are. The B and the 58, are they opposite, adjacent, or the hypotenuse? Well, doesn't really matter what order. There's a winner. This is definitely the hypotenuse. He's across from the 90. Who is this guy right here then? He's either opposite the 70 or adjacent. Notice how he's touching. He is the adjacent on this guy. So dealing with adjacent and hypotenuse, that would be these two dudes right here. I need the cosine. So we will do the cosine of the angle measure equals adjacent over hypotenuse. So B over 58. Do you see how that worked this time? It's like you never know which one's going to be on top, if it's the letter or the number, until you decide who they are. So adjacent's on top, hypotenuse on bottom. This is actually way better than before, because all we got to do to get B all by itself is get rid of this stupid divide by 58. And you get rid of a divide by 58 by multiplying both sides times 58. So I'm going to write 58 times the cosine of 70 equals B in that case. And I really like it this way as opposed to like cosine of 70 times 58, because you're not allowed to like multiply those two numbers together, because this isn't a 70, it's a cosine of 70. Like, we should be putting them in parentheses, but I get lazy and I don't put them in parentheses all the time, so I just always put the number in front of that guy. And then you go punch him in. 58 cosines of 70, close those parentheses, and about 19.8 is what I'm getting on that dude. So it gets easier and easier and easier the more you do it. It just takes practice. And you got to learn to talk yourself through it. So first, put all the info in the picture. Little a, little c, and then what you got to realize is you have to focus on this guy, the angle that they're talking about, like who is opposite, adjacent, and hypotenuse. So I do kind of require that we put these in here as we are learning. Like maybe in a week we don't need to do that anymore, but on the beginning worksheet, let's put the OPPs and HYPs and the ADJs if we need them. And opposite and hypotenuse, nope, nope, yep. Do you see how it's got an O and an H with it? So out of sine, cosine, and tangent, we will use the sine. What goes next to him every single time is the angle measure that we are focusing on, and it will be opposite over hypotenuse, so 27 over C in that case. And this is the sucky one, because the divide by C is downstairs. We need the letter to be upstairs for us to solve for it, so I need to get rid of that by multiplying. So C times the sine of 42 equals 27. And then to get C all by itself, there is a times sine of 42. I will divide both sides by the sine of 42. And we'll punch that in. I forgot what it was. 27 divided by sine of 42. 27 divided by sine. Let's clear everything out. 27 divided by sine of 42. And hopefully you punched it in before I did. I got about 40.4. Do you see how, like, this guy was what we're trying to round to, but he's 5 or larger, so we got to go to 40.4. 40.4 in that case. So weird stuff, man. Just finding a missing side length today. So the only thing, since we flipped to the new side of the page, I always like to write the word SOH CAH TOA on the top of the page every time. And here's the truth. If you can't spell it, you won't be able to use it right. So SOH CAH TOA. Please, please, please learn to spell that word. And I have tried to trick you on this one by moving this thing to the bottom, which we rarely see him. He is the hypotenuse down there, right? So be very, very careful. Just because the triangle is rotated, it doesn't mean that the hypotenuse is always on the side. So let's realize we need SOH CAH TOA for this. He is a right triangle, and I have a mixture of side lengths and angle measures, and I don't have like enough sides to do Pythagorean theorem, so I focus all my attention on him, and realize who these letters are. Who is this A? Opposite, adjacent, or hypotenuse? He is opposite. Who is this 5 in relation to the 17? He is adjacent. Then I go to SOH CAH TOA and see which one is dealing with opposite and adjacent. Here's my winner chicken dinner. It's the tangent. The tangent of 17 is going to equal either A over 5 or 5 over A. How do I know which one? It's the order that these are in. The first one is on top, opposite, and the bottom one is the adjacent in that case. So to solve for A, love this. All I got to do is get rid of the divide by 5 by multiplying by 5. 5 tangents of 17 will equal A, and we'll go punch that in. 5 times the tangent of 17. And it'll give me about 1.5. A is about 1.5. Cool. I bet we're feeling a whole lot more comfortable with it. We've only done 5 of them, so we could still be a little shaky. But now it's time for the story problems in this situation. So when the sun is up 32 degrees from the horizon. So we need to learn to understand the pictures because we're going to have to draw a lot of them ourselves. So the horizon is like basically a horizontal in the picture. It's fancy talk for the ground. The wall of a store casts a shadow that is 25 meters long. So I got the 25 meters right here. And by the way, the sun is up 32 degrees from that. It says, how high is the wall? We will do that X. And I bet you know we are assuming that that is 90 degrees right there to where the store and the ground meet. So can you see we've got ourselves beautiful little right triangle here in this case. And I need SOH CAH TOA because I've got an angle measure and some side lengths that I'm trying to mess around with. So if I focus all my attention on him, who is that X? Opposite, adjacent, or hypotenuse? He is opposite. And who is this 25? He is adjacent to it. So we shall use SOH CAH TOA, which I should have had written here. It's at the top of your paper, right? SOH CAH TOA. Come on, Mr. P. CAH TOA. And realize which one of these guys deals with opposite and adjacent. It is the tangent, right? So I'll do the tangent of the angle measure, which is 32, and that will equal opposite over adjacent. And then we shall solve. So multiply both sides by 25. And yes, you need to show me all this work. So then I go punch that in, 25 tangents. I believe it was 32. Double check that. And I got about 15.6. Was it 32? Yes. So that store is about 15.6 meters tall. Cool. So we'll throw the label in there because he was a story problem. And then lastly here, I think this is the last problem. That was an angle of elevation problem, by the way, guys, because they looked up from the horizon. This is also an angle of elevation problem. We got a dude here. He is 5 feet off the ground. That's their eyes, right? So here's the ground. I'll use green for the ground because that's prettier, right? There's the ground. This dude's eyes right here is 5 feet off the ground. Cool? And they are 20 feet away from a flagpole, so 20 feet right there. It says a person has to look up 40 degrees at an angle of elevation. So this is a very important thing to put in your picture. This is where the person normally looks. This is what they call their line of sight. That is straight ahead. Like people normally look straight ahead. Well, to see the top of the flagpole, something had to move 40 degrees up. Either this guy tilted his entire head or he rolled his eyes or something, but he had to look up 40 degrees to see the top of the pole. They ask how high is the pole? Well, we got a small problem because like we can only deal with this orange thing right here. I'm sorry, I keep hitting the wrong buttons, guys. This orange thing right here is making us a right triangle, and we could find that, right? The problem is that's not the entire height of the pole. There's also this remaining down here, which is an additional 5 feet because that's how high the guy's eyes are. So once we find X, we just add 5 to it to kind of get to our final answer. So let's focus first on finding x. Let's see who this guy is in relation to the 40. Is he opposite, adjacent, or hypotenuse? He is the opposite, and the 40 is the adjacent to it. So let's use the tangent. The tangent of 40, that's the angle measure, is going to equal opposite over adjacent. And then we will multiply 20 times the tangent of 40 is going to be x. So we'll punch that in. 20 tangents of 40, bada boom, about 16.8. So x is about 16.8. But remember, that's only this thing. We have to add 5 to it and get 21.8 is approximately the height of the pole in that case. Realize he's not x. Okay, x is 16.8. Don't say x is 21.8 because that's not right. X is about 16.8, and we just add 5 to it. So all of those were angle of elevations. We are looking up. Here's another one called an angle of depression. We are going to look down. So from the top of a building, you look down at an object on the ground. I wish I would have put the word object right here. This is what we're looking at, is some sort of object on the ground. Your eyes are 55 feet above the ground. Can you see I already have that in the picture for us? And the angle of sight, called the angle of depression, is 50 degrees below the horizontal. So this is the hard part for people to understand, is if you're standing on top of that building, you see how you're normally looking straight ahead? For you to see that object, you have to look down 50 degrees from that bad boy right there. So that 50 degrees goes from the line of sight down, which is weird because it is not inside this triangle that we are using, which of course is a right triangle. But here's what we know. We will assume that that green dashed line and our ground right here are parallel to each other. And this dude right here are alternate interior angles. So if that one's 50 degrees, this one's 50 degrees. So there I got myself that angle inside the triangle. And the question asked, I guess I kind of skipped over that, is how far is the object from you? Well, that's kind of weird because we would think we would want to find this distance right here, but that's how far the object is from the building. When they ask how far is the object from you, it would really be like the straightest distance between there. So it's going to be the hypotenuse in that situation is what we're looking for. And focusing all of our attention on this guy right here, we also have the 55. Who is the 55? He is opposite. So I've got opposite and hypotenuse. That will mean we'll do the sine function. So the sine of 50 will equal opposite over hypotenuse. X is downstairs. That sucks, so we'll get rid of him. And I'll have x sines of 50 equals 55. And then to solve, I will divide by the sine of 50. And we will punch that dude in. Right? 55 divided by the sine of 50. Bada boom, about 71.8 feet. X is about 71.8 feet, which does make sense. It should have been longer than 55. Remember, the hypotenuse is the longest side. So, yes, yes, yes. Put all the little things in the picture, opposites, hypotenuses, all that crazy stuff. Show all the work and make sure that calculator's in degree mode. Let us know if you can't get it there or if you have any other questions. Have a good one.